All right. Well, welcome back, everybody. We are going to proceed with our second session. We have a few more presentations to go this evening. Before we actually start with the presentations, though, I have to just share one thing. One of the juniors in the Goodwin Hearing Center is like the most thoughtful person. David Mulapa here, just kind of his own initiative, did this amazing thing. And we have these like really cool, like reusable cinch sacks for all of you GNCE students. Make sure you take one of these on your way out. As like kind of center thing. Yeah, David. It falls to me to introduce our next speaker. This is another case. I'm not Liam's advisor, but I kind of wish I could. Liam is so great, and working with him in this seminar and in class over time, it's been just such a joy to follow his work through the center and learn about a very cool internship last summer. And Liam has just, if you know Liam, he's added so much. He's done so much environmental work at the campus as SGA's sustainability chair. He's added so much to the center over time. So it's really exciting to see Liam, your work kind of wrap up successfully this semester too. So Liam will be speaking on urban climate mitigation under federal right-wing regimes.
All right, hello everyone. As Derek mentioned, my name is Liam Remus. I'm a government environmental studies major. Tonight I'm just going to be presenting about urban climate mitigation under federal right-wing regimes. So kind of my interest with the center when I first came in here, I had some experience working with cities directly through some of the engagements I was in. I'm from Boston, inside the city, one of the few people who's actually from Boston. And then I have some experience on urban sustainability issues. I did a program called Green Ambassadors, which took place in the Boston Harbor Islands. There I did like urban environmental justice issues, climate mitigation, climate reports, looking at the city, just how they can reduce climate emissions, and then the island itself. And then also I worked as a city council intern in the city of Boston. There I was doing similar stuff, more the politically sad stuff of urban sustainable policy, looking at hearing orders, trying to expand solar panels on municipal buildings, more net zero buildings projects, and just looking at kind of like reduce urban emissions specifically through buildings and solar policy. And my main interest for looking at cities within my project is because cities actually account for over 70% of global emissions for greenhouse gases. A lot of them take place in cities. That's obviously where a lot of people live. So kind of you'll see a push like internationally right now to mainly reduce climate emissions specifically through cities. You see a lot of like international groups made up completely of cities. So with my project, I kind of want to see under the worst case scenario for a city under a federal right-wing government, how can they reduce their climate emissions? And then kind of going into like my courses, what I've taken to prepare for this project is, taking Center to do 3 courses. I took CC Power and Equality to look more about inequality issues, environmental justice, kind of like taking that into the factors in my city. Took community agriculture, Eric knows in here, look at more of like just a sustainable organization and within municipalities in London, and seeing how communities get together and react for like more sustainable causes. And in urban sociology, I took last spring, again, looking more at urban, more like kind of how they operate, different dynamics within the cities, kind of seeing power inequality issues, also just how policy gets passed, adapted, and its impact on the people who live there. And then over the summer, same with Adrian, as you might have heard in his presentation, where I worked for Sustainable CT, worked specifically in Lower Connecticut River Valley COG, or River COG as it was for short. That was responsible for 17 municipalities in the Lower Connecticut region there I was kind of working mainly with town volunteers, municipal officials, town officials, trying to get them certified through the sustainable CT application process. So it was a lot of meeting volunteers. There was a lot of like long, just kind of like getting it within hands-on experience of the city. A lot of meetings, a lot of checking, making sure paperwork was filed, because as kind of mentioned, like sustainable CT is kind of similar to like a LEED style certification project, but for citywide actions. So cities just have to show data, show they're working on projects, and fulfill these requirements to show that they're reaching their carbon emissions, they're making progress towards more sustainable initiatives more generally. So that kind of brings me now towards what I've started this spring, working on the school year, and my overall kind of question that frames this project is how effective are municipalities at mitigating carbon emissions under right-wing federal regimes antagonistic to climate action? And then underneath that kind of larger question, I really wanted to ask how they utilize their local regulatory power, whether it be building ordinances, any waste requirements, then things like that, to see how they're operating through their realm of power. How are they burdened by the federal government? Are there specific grants that they no longer have access to? Is there somewhere where the federal government's stepping in and taking over their power? And how they utilize their private partnerships and multi-municipal organizations to strengthen their work. As I said, kind of like those multi-municipal organizations that work with different cities, a lot of them provide funding, like C40 Cities is one. Also, like just private partnerships working with any NGOs or any like private companies, just kind of finding finances or just policy expertise support to push climate action. So the cities I selected for this report, there were more to begin with, but it really just came down to two, just due to available information and also kind of like similar dynamics and their experiences. So the first one is Rio de Janeiro in Brazil, specifically looking at it under former President Bolsonaro from 2019 to 2023. It has a population of a little under 7 million. They emit about 93 million metric tons, and it's also a federal republic, which is why I wanted to put it up against New York City in the United States, specifically looking at the time frame under former President Trump. It has a kind of similar population, a little over 8 million. It emits a little bit less, 52 million metric tons of CO2 based on its 2016 measurement, and much like the Brazil, it's a federal republic, meaning it does have some separate regulation power separate from the federal government. So, and then kind of like determining the sectors, I then have to break it down to measure the impact it was having in these three different areas. First, I looked at buildings, how a city was managing building emissions, or how it was pushing building owners to kind of cut their own emissions. Next was transportation. How is it trying to expand into public transportation or biking or walking, or just trying to reduce car use in general? And then looking at energy, how effective was the city at power or expanding like solar, or looking into alternatives or energy efficiency status. So these sectors kind of seeing how effective over the period of time the different cities were at reducing emissions and enacting new policies. So starting with New York City, it had two main governing reports during that 4-year period. The first one was a 1.5 degrees Celsius plan, which sought to put New York City in line with the Paris Agreement after Trump left it in 2017. And then later it was one New York City 2050, which was more in line with a more like kind of like robust Green New Deal kind of approach to climate mitigation, much more focused on a lot of like social inequalities as well as climate mitigation cutting, very like in-depth report. So kind of based off all these those dogmas or those projects, and then like kind of what came out of it, it was a lot of like strict municipal codes that cut emissions, and the city kind of like that's like their first building they took towards building codes. It was much more of the stick approach, kind of punishing, or well, not like strict building ordinances about like emissions have to cut and efficiency standards they have to make. So much more just trying to cut emissions, set different standards for each year. And then renovating municipal buildings net zero was also another point, just kind of taking what the city owned, the different buildings, obviously anything from like train stations, city hall, libraries, schools, things like that, trying to get those energy efficiency. You can get like a deep cut of your municipal energy. And then creating a seed-based funding or commercial property access to clean energy. That's just a program for buildings and other groups to kind of apply and get funding for different, anything like with like clean energy or just getting support on any renovation projects. They're also electrifying the municipal vehicle fleet, installing electric chargers. It's currently 1,200 installed for anyone to use, and then increase bike pedestrian infrastructure with 329.3 miles installed, and then solar installation incentive programs, kind of less about like directly putting in solar, but more incentivizing private owners to take their own steps. And then moving on to Rio, it's kind of like interesting to see more kind of differences. They've taken a much more sectored approach, while New York's much more trying to get the city all encompassing to adapt to more climate regulations. Rio is kind of like specifically right now investing in their latest report, which is a sustainable development plan shown here, to kind of get their downtown area and like kind of focus it on that area at a time. There's much more beginning with there's a lot more kind of like, and hopefully like expand it out and see the rest of the city. They're doing this less so. There is some more wants to have more building ordinances, but it's a lot more tax incentives to try to get the company or private owners to become more efficient with their energy use and also produce more clean water, less waste production. So it's much less, they have less power than New York to kind of like put this hard stick approach. It's more kind of be incentivized to like take their own steps. There's also non-emission buses, but this program was paused when Bolsonaro came to power because a lot of it had to do with federal grants provided by the federal government. And when Bolsonaro stripped a lot of the federal power and funding, those programs sadly went away. There's also an expansion of pedestrian and bike infrastructure. A lot of this does have to come into the sectored approach where the downtown area is kind of seeing a lot more has seen investment with pedestrian bike infrastructure, but there's more general plans to kind of get the city more in line. Also, efficiency of streetlight energy system, that's also been put on pause because a lot of that was due to their inability to secure funding and kind of find both a builder to kind of install those lights and also create some more federal power. And then instead, what they decided to do is just to look more at their municipalities and expanding their solar on school and municipal buildings. So kind of as we saw in New York, more kind of getting their municipal approach into there. And then their next one, kind of more for the energy sector, is they're going to kind of collect biogas for the different waste. So it's not really the most ideal form of energy, but it's kind of taking their waste problem and collecting more methane off of it, which is an approach. It may not be the most ideal, but it's kind of more kind of their way of solving both their waste problem and trying to get some energy out of it. So more kind of the conclusions of looking at these two cities is that success will definitely vary by city. As you kind of see with New York and Rio, there's more of a global north and global south divide. New York has much more money, much more regular kind of like strength. They have a like larger GDP and everything. So it's really easy for them to enact these strict building codes, while Rio kind of has to rely a lot more on private partnerships, and they're also kind of incentivized to get more economic development. As I kind of mentioned, the carrot and stick approach, that's kind of like where to will. If you have a lot more power, you're more willing to use the stick, but if you're still trying to get investment, you're going to be more willing to use your carrot. And then kind of like the policies are virtually being a lot driven by like kind of like more of like where there's business interest, where there's capital, like New York. Another reason why they're very much willing to like more set in these retrofits and building efficiencies is because it's really expensive to build new construction in New York. So there's much more of an interest in developers to kind of seek more renovation projects and less total rebuilds. So there's kind of like that incentive. And then also if you look in Rio, a lot of the natural gas is very much, or biogas collection is inspired by a lot growing biogas industry in there, kind of like spurred by deforestation primarily. But I guess in the Rio sense, it's more using more waste. So it goes, well, it's not identical to the biogas collection from deforestation. It is a form kind of like working in that growing industry. And then kind of like the biggest one is federal grants and research are the biggest loss to cities. So the federal government, as I could find, couldn't really do much directly to stop the city's action or its regulations, but they could take away a lot of funding, as we saw mostly in Rio, where Bolsonaro just kind of killed many like environmental departments by just not staffing them or just cutting all their funding. And we kind of see this a little bit. We saw this a little bit less so with the United States, mainly because it was much more harder for like the Trump administration to fully like take down the EPA or anything like that, but there was definitely a limit to research that was published out of the organization, as well as just not staffing certain positions. But with a lot more like long-term positions in that agency, it's harder for them to make more short-term changes like that. And then thank you to everyone in the center, Jen, Kelly, my advisor, Professor Dawson, Derek, and everyone else who helped me throughout the years.
Introducing our next speaker is Eric. Professor Vukisevich is gonna introduce our next speaker.
Sure, or whatever. Awesome. I thought I was gonna miss it because it was in the first half. So Quincy has been working with me since September on what turned out to be her honors thesis as well, looking at mushroom biodiversity around New London. So we've got all these wonderful open spaces, and I and others have been foraging in them and have started to be curious about where should we be looking to find biodiversity, knowing that fungal biodiversity is really important for all these things. And she took this on and dove right into it and identified a ridiculous amount of mushrooms, probably an overwhelming amount at some times, but found some really interesting things, and has been a pleasure to work with. And I'll introduce Quincy Dowling.
Thank you, Eric. Good evening, everyone. I'm Quincy. I'm a biology major with a cellular and molecular concentration here at Con, as well as a scholar in the Good Center. And my honors thesis and Good SIP is on the effects of trailside and non-trailside sample collection and tree communities on the biodiversity of mushroom-forming fungi in public green spaces of New London, Connecticut. So to start us off, why mushrooms? Why is mycology important? And there's a lot of answers to this question. Mushrooms, while they are the reproductive structures of fungi, they play many ecological roles. Fungi are essential in nutrient cycling, returning nutrients like carbon back into the soil. They're sources of food for animals and humans as well. And they can even have symbiotic relationships with plants. These are mycorrhizal fungi, which play a really essential role in providing plants with nutrients like phosphorus and nitrogen in exchange for carbon-containing molecules. So fungi have a multitude of relationships in the environment that can really shape the biodiversity there and the health of ecosystems. And fungi as a kingdom is incredibly diverse, and there has not been an immense amount of research into the full extent of fungal biodiversity compared to, say, animals or the plant kingdom. And so it's a really important field for us to pursue because of the importance of fungi for supporting plant communities, improving ecosystem resiliency, and as well as the many applications of fungi for providing accessible sources of food, as well as medicinal compounds, and even the antibiotic drug development processes that are becoming even more important in today's world. So my project is focusing on trailside mushroom foraging in urban environments. And over the last few decades, there has been a rise in popularity for mushroom foraging, and because it's It's an enjoyable activity. It gets you outside in nature. It builds a connection to nature, as well as it allows people to access sources of food and medicinal compounds. And so an important question with this rise in popularity is, where can people go to find the diversity of mushrooms that they're seeking? Does it require going to a more rural location? Can it be right in your backyard? And so this brings into question what factors influence biodiversity in general. And disturbance is a very large factor that can influence biodiversity. And whether that be human-made disturbance or natural disturbance. But one example of disturbance is the presence of trails in a lot of green spaces. So for example, trails receive soil compaction from footfall or foot traffic, as well as an increase in deadwood along trailside from branches and undergrowth being cleared along trails. And so I'm focusing on how this disturbance on trails can possibly impact mushroom biodiversity. And some other factors that can influence fungal diversity are the climate, precipitation, and temperature in their environment, and as well as the plant communities that are present. And so in my project, I'm analyzing how all of these factors may be at play in an environment like New London. So this leads me to my research question, which is, what are the effects of trailside disturbance and tree communities on fungal diversity and community composition of mushroom-forming fungi in New London, Connecticut? And an important detail here is that I'm specifically focusing on mushroom-forming fungi, because not all fungi form mushrooms, but I'm specifically looking at mushroom-forming fungi because of their application as an accessible food source and an accessible source of medicinal compounds. So to go about sampling the mushroom biodiversity in New London, I identified 6 sampling sites, which are all public green spaces here in New London and Waterford counties. And within each site, I created 2 foraging areas, or 2 areas that I would be sampling. One was along either side of a trail, and the other was an undisturbed plot in that forest, and in the same type of ecosystem as my trailside plot. And each foraging area within the site and each site was visited twice between the months of September and October. And each sampling occasion was approximately a few days after some rainfall, which is beneficial for fungal growth, and usually is a triggering factor for mushroom formation. So that allowed me to optimize my observation of rooting bodies there. And when collecting mushrooms, I collected one morphologically unique mushroom per species. So this is because fungi are different in terms of how we think of an individual fungus rather than like an individual tree or animal. An individual fungus can form multiple mushrooms, and it's still considered the same organism. So I was not measuring abundance of mushrooms, but just the species richness of different mushrooms in that area. And in order to analyze factors such as climate and precipitation, I collected data from NOAA. And so here are some photos from my sampling process. In the top left-hand corner there, I have a photo from Mammacoke, which is part of the Connecticut College Arboretum. And through my sampling processes, I observed many really cool mushrooms. It was incredible to see how much diversity we have in New London. And it was quite a process to go through the identification of all these mushrooms. I had to examine their substrates, unique morphologies of these mushrooms, their textures, size, the presence or absence of specific structures on the mushroom. But I did collect photos of each mushroom to aid me in that process. And in terms of identifying the species, I was not able to get to the species level with my identification for all mushrooms, but I was at least able to get to the genus level for my identifications for the most part. So how I measured fungal biodiversity, first I want to say that when I say fungal biodiversity for my project, I'm specifically talking about the biodiversity of mushroom-forming fungi. I was not able to measure the presence of, say, microscopic or mycorrhizal fungi that did not produce fruiting bodies. And how I measured biodiversity was through fungal species richness as well as fungal community composition. And for assessing not just the impact of trails, but also the impact of tree communities, I measured species richness of trees that were present in my sampling plots and conducted a Shannon diversity index of those trees. And I also recorded the proportion of ectomycorrhizal trees that were present in those sampling areas. And that's because only specific tree species are able to be hosts for ectomycorrhizal fungi. And so those are important to take account for in the tree communities that were present. And so finally, to combine all of those factors that I was observing and measuring, I conducted multiple ANOVAs and permanovas, a constrained analysis of principal coordinates ordination, which allowed me to compare the fungal community composition between my different sites. And I also conducted an indicator species analysis to see if I could find any species or genre of fungi that could be predicted in particular sampling areas rather than others. So for the first part of my question, I was able to immediately, once my sampling was done, compare all of the undisturbed plots that I had collected mushrooms at versus the trailside sampling areas. And I analyzed this data, and we determined that there was not a significant difference between these two areas across my 6 sites. So that goes to show the incredible resiliency that fungi can have. They are very different from other taxa in some ways in that they can thrive in very unique environments. But some other factors were more differential in how the fungal species richness varied, and so I'll get into that more. So looking at each site, I have this dot plot here that shows 1 dot for every sampling occasion at each site. So each foraging area and each site was visited twice, so we have a total of 4 dots. And we can see here that the blue dots representing trail and the orange representing plot they do not always follow the same trend across each site. So that indicated that there was an interaction happening between the trailside disturbance, the presence or absence of the trail, and each site. You weren't going to always find more diversity along the trail or always find more diversity in the plot. It depended on where you went. And so to confirm this, we conducted a permanova test and observed that the factor of site was not entirely significantly impactful on the fungal species richness. The p-value was slightly insignificant, but it was able to give us like a 92% confidence that site would be a significant factor. And furthermore, it led us to do some additional analyses on the interaction between the site and the disturbance and include that as a factor in our future ANOVAs. So next, I got to look at the fungal community composition with my CAP analysis, and this was really interesting. So this ordination shows 1 ellipse for each sampling site that I went to, and the ellipse represents a 95% confidence interval of the fungal community at that site. So overlap between the ellipses represents similarity in their fungal community composition. And overall, we could see a lot of overlap in these ellipses, which is really interesting. But one distinct point is that Mitchell Woods, which is on the leftmost part of the graph there, had some of the least overlap with some of the sites, and that was also one of the least species-rich sites that we observed. And when we were looking at our permanova for the fungal community composition, we did determine that site and seasonality were significant factors. So moving on to the impact of tree communities and tree diversity on fungal species richness, here I have a table showing the different ways in which I measured the diversity of the tree community. So started with the tree species richness and then used that to calculate the Shannon Diversity Index. And finally, we calculated the percent of those trees that were present that were ectomycorrhizal. And so in our ANOVA tests, first we found out that tree diversity was not a significant indicator for fungal species richness, but the percent of ectomycorrhizal trees was a significant factor. And here I've highlighted some of the sites that have the highest percent ectomycorrhizal tree species, and those were also some of the sites that had the highest overlap with other communities of fungi between other sites, which is really interesting. And just to reinforce that conclusion that the percent of ectomycorrhizal trees was an important factor here, we just created this plot between fungal species richness and the proportion of ECM trees. And again, we determined that was a significant factor for determining fungal species richness. So returning back to my overall question, first, we determined that trailside or non-trailside foraging did not impact the fungal species richness that was observed. It was significantly impacted by the ECM trees that were present, but not by the tree diversity in general. And we also determined that site, climate, and seasonality, or a point during the season at which I collected the mushrooms, was not significant in changing the fungal species richness observed. But it was really interesting that the sites with the highest percent of ectomycorrhizal trees also tended to have higher fungal species richness. And some of the trees that we saw most commonly associated with the fungi there were oak and birch trees. So for the next part of my analysis, looking at the fungal community composition, we saw that this was significantly impacted by site and seasonality. And so seasonality, again, is just reflective of the change in season from September to October, which is late summer into early fall. That reflects changes in temperature as well as precipitation. So that's going to change the moisture that's available for fungi. And fungi are also very sensitive to temperature. So all these factors are going to make different species more likely to thrive at different points in the season, as well as opening different niches that different fungi can utilize at different points in the season. And we also conducted an indicator species analysis, and the results were that the Amanita genus was an indicator species for the Mammocoke site, which is one of the most species rich, as well as similar sites to other sites that we included in this experiment. And Amanita is a ECM or ectomycorrhizal genus in general. So this was really interesting to see how not only did Mammocoke have a higher percent of ectomycorrhizal trees, and not only was it more diverse in its fungal communities, but it also had this genus that was reflective of the community there. And for the trailside plots, as compared to the plots in an undisturbed area of the forest, we saw a high presence of the Mysterium genus, which is a saprotroph fungi, meaning that it likes to decompose dead organic matter, such as trees or other organic material that may have been cleared from the trail. So for just some conclusions, the proportion of ectomycorrhizal trees was the most important factor in determining fungal diversity. And the disturbance of the trail or not having a trail had little to no impact on the diversity there. And so this has a lot of implications for forest management and how we can take care of our parks and green spaces, as well as the trails that are there. And it's also good news for the accessibility of mushroom foraging, because it means that the public can access these green spaces along the trail side and not have to worry about leaving the trail side in order to find a great amount of fungal diversity. So for some acknowledgements, I'd like to say thank you to my advisor, Eric, of course, as well as all of the faculty and staff at the Guggenheim Center and my peers, my readers, who are helping me with my thesis. And a huge thank you to my roommate, Mara, who had to live with lots of mushrooms in our apartment for 2 months.
I think we'll do the same thing in this session as we did before, and we'll take questions for all the presenters at the end. And Jen is going to introduce our next speaker.
Good evening, everyone. I think you all know me. I'm Jen Lamb. It is my absolute pleasure tonight to introduce Ellie. I was not lucky enough to be Ellie's advisor. Ellie's advisor can't make it tonight, but I do know Ellie, I would say pretty well. Would you say pretty well? Yeah. So it is such a joy of mine to be able to get to know the students in our center from the time that they apply through all of the work that they do. And Ellie is never without fans. So you'll see that there's lots of people in the audience, including her incredible parents that came here tonight. So let's just embarrass Ellie some more, right? But I'm really excited to see the passion and tenacity that Ellie has had. Again, this was an era that it was very difficult to get internship and research experiences because with the post-pandemic, pre-pandemic, during pandemic, wherever it was, I think there's been a lot of a shift in how recruiting and how experiences are able to be planned for and obtained. And Ellie really persevered. She's done an amazing job, and I think you'd be really excited to see all that she's done with her seal stranding research. So without further ado, the most amazing Ellie.
Well, thank you all for being here. So this is kind of a two-part project, so I'll take away the first half, and then my colleague Sarah Padilla will wrap up the second half. So my name is Ellie Piper. I am a biology major, and I'm going to talk a little bit about how I analyze local seal stranding data with the Mystic Aquarium and foreign conservation efforts. So my environmental interests kind of stem from my upbringing as a sailor. So growing up, I always had a deep fascination with the ocean, how it worked. In the middle image, you can kind of see me playing around with it. So I was really interested in how everything worked. And so that kind of sparked my interest in joining the Goodwineering Center. And in order to diversify my own academic interests, I wanted to join the center and kind of focus a project on the ocean. So my initial proposal when I applied into the center was geared towards my relationship with marine conservation and the relationship between the rescue and rehabilitation of marine animals. So this idea kind of fueled my path throughout the center, but I was ultimately trying to see if I could address and manage the issues that humans pose for marine mammals, focusing on the injuries and illnesses that are frequently found within rescued marine mammals. So just a brief little timeline of my journey. So when I joined the center, we first had our little service learning experience with Avalonia, where I similarly worked with Sarah on a data collection project. So we worked to create a living document for Avalonia. Again, kind of piecing through Excel, a bunch of historical documents to kind of come up with data for them on a new acquired property in North Stonington. Then in the fall of 2021, I studied away in Galway, Ireland, looking at toxicology and marine habitat courses to kind of expand my interests. And these were more of the 3 courses that I then continued to complete in the spring of 2022. As Jen kind of mentioned, it was hard to get internships and things during the COVID year. So in the spring of 2022, I reached out to a colleague at the Cape Louvre Institute, and I was able to do a data collection experience with them, where I looked at instances of marine mammal bycatch globally and kind of locally, and tried to figure out the policy behind it, what NOAA fishery does, and why this is occurring. Then this past summer, I was able to volunteer with the Mystic Aquarium, looking at animal husbandry work, and kind of continue my interest with marine mammals. And then I ended up at the Bermuda Institute of Ocean Science, where I kind of shifted from the marine mammal aspect and looked more at coral reef ecology, which was really unique to kind of diversify my experience, but also help me understand a little bit more about human impacts on coral reefs as a whole. And so all of these projects kind of went into culminating what my final SIP is, which is analyzing seal stranding reports from the Mystic Aquarium to raise awareness and inform conservation efforts specifically for their animal rescue program. So what does the animal rescue program do? The goal of the program is to enhance the health and the welfare of animals in their care, to improve the understanding and protection of wild animals and their environments, protect the fragile marine resources, and foster a greater appreciation for the ocean and the animals that come from them. So this is one of few teams across the country that deal with responses for all animals. There are a bunch in Florida and California that deal specifically with sea turtles, but this is one that can respond to seals, cetaceans, so dolphins, whales, sea turtles, and basically anything that washes ashore. So they respond to calls that are on the northeast coastline through Connecticut, Rhode Island, Massachusetts, Fisher's Island, New York, and they provide support for other facilities too. So they have some transfers up from Bermuda as well as from California, and so anything in their care will be transferred in, and then they will hold them for about 2 to 4 months before releasing them. So they respond to 3 types of calls. They respond to about 150 per year, which is a lot. But they range from strandings, sightings, and then transfers. So it can kind of be hard to understand if there is a stranding, which is when an animal comes ashore, either dead or alive, especially if they are seals. So seals do come ashore just to land or to rest, to birth, and for also molting throughout the year. So they do have to kind of talk a little bit more with the person who makes the call to understand if a rescue team is needed to be sent out to this particular part. The animals that are stranded are rescued, rehabilitated, released, and then they put little trackers on them, which you can see in this image in the lower right, and then released and recorded to make sure that they are kind of acclimating to their new environment properly once they release them. So why seals in particular? So I wanted to particularly expand the work that I was doing with the Cape Eleuthera Institute and further investigate how humans are posing threats for marine mammals by understanding what causes stranding. So what causes illnesses and injuries and leads to these animals washing ashore or being sighted so close, because sometimes seals don't necessarily tend to come so close to shore. So humans can typically cause seal strandings with habitat loss, propeller strikes, which is when a boat will hit a seal, sadly, or entanglement with fishing gear. So I actually just got this photo today, but this one is pictured with the seal actually has some fishing gear wrapped around its neck, which is unfortunate. And so I wanted to look specifically at this data set because the aquarium has a really large number of seal strandings. So I thought that this information surrounding seals would be the most useful for them in order to guide their conservation efforts. I don't know where I lost my. I'm so sorry. Anywho, these seals are also important keystone species, so it's important to protect them because they eat things like squid, fish, but they also are food for other predators. So they kind of balance out the ecosystem, and without them, it would lead to ecosystem decline. They also help cycle nutrients, which can go from land into the water and then help create an abundant cycle of organisms. But ultimately, by looking at this data, we can help assist the Mystic Aquarium and help aid their own actions if we can figure out where the seals are coming up more, what time of year, what type of seals, and we can help them figure out where to best put their efforts. So the project goals, the research questions that they wanted us to specifically look at were which species had the most popular calls, which were the most popular months for calls, the most common call type, so between stranding, transfer, and sighting, and then the location with the most number of calls. So I divvied this out based on state. They did have it based on area within the state, but that was a little bit more complicated to try and figure out. So we're trying to work on this with them currently, but we're trying to come up with a deliverable for the training program, which will ultimately help raise awareness for the public, because it'll ultimately be a QR code or a website that the public can go to when they visit the aquarium to see what kind of efforts this program is doing. And then it will ultimately help guide their own conservation efforts. So at first, we met with Sarah Callan and the whole entire team. They gave us a little brief rundown of what the facilities are like, what they do, and then they sent off the data to us. So Sarah will talk a little bit more about what the data looked like, but it was a bit doozy to work with. They only gave us data that was categorical, so no numbers were involved, which made it a little bit tricky to analyze. But ultimately what we did is created bar graphs based on general trends, and then we looked at chi-squared tests. So these are statistical analysis that looks at two categorical data, two categorical variables, and determines whether or not there is a relationship between them. And then hopefully, we're still working with Sarah, she emailed me today, we're hoping to produce a deliverable in the end for them. So this is a little outline of just what their facilities look like. So this is one of the workers preparing meals for them, for the seals that they have. And these, where this woman is crawling out of, is where they keep all of the seals. So when they come in, they have to make sure that they're put in separate containers, that they don't spread illnesses or disease to any of the other seals in their facilities. So yeah, this is what the data looks like. I'm not going to get into it. That's what Sarah's going to do. But essentially super messy and not fun to work with in R. The way that some of the people put data points in here, if you ran it through R, you realize you'd have to run it again because someone missed something somewhere. So a little bit complicated and took some time. Okay, but so these are the seals that we generally saw. The gray seal had the highest number of calls. Next was the harbor seal, the harp seal, and then the hooded seal. So the gray seal and the harbor seal do tend to stay in the Northeast. These are the seals that actually breed here, while the hooded and the harp seal migrate in. So that's kind of why we tend to see them a little bit less. But this is just a visualization of that data. So a little bit more than 600 calls from the 2011 to 2023 time span, which was the amount of data that they had sent us. And then the harbor seal and the harp seal were a little bit less. And we also wrote down unknown seals. So the team, whenever they responded to calls, would confirm whether or not the species that the caller had said, oh, maybe it's a gray seal. They would confirm it, and if they had no idea, they would put in unknown seal. Next, we kind of looked at the general trend of calls per month. So you can see that most of the calls occurred in March and April and tend to peter off towards the end of the summer and then have no calls in the winter time. So I don't know if this is because people aren't normally out and about on the beaches in the winter time, but I was expecting to see more of trends in like June and July when there would be more people out and more people potentially causing strikes or entanglements or things. But this did tend to make sense when I looked at it both on a species basis and also on an age basis of the particular animal. So it's a little bit hard to see some of these, but this is pieced out by number of calls by each species within each month. So you can again see the same trend as the other figure, with the harp seal having the most number of calls in March, and then the gray seal having the most number of calls in April. So this is for the harp seal at least, this is most likely due to its migration pattern it's usually up to Canada or Newfoundland, where they will go and they will then breed. So I would guess that it is most likely that we see them here in this area as they're traveling up then to go breed within the time of March and April. So we did run a chi-squared analysis for this data as well. So we did 100% can figure out that there was some form of relationship between the type of the species and the month. So because the value that we found was less than 0.05, it meant that there was a statistically significant relationship, which again Sarah will talk about later. So then I also looked at the same data, but pieced out by the age of the the animal that was stranded. So in March, and about March through June, we can see that the ones with the most calls are either yearlings or less than a year old. So when I looked at the breeding time for gray and harbor seals, this tended to make sense. This was the time in which both species were breeding, so it was more likely that, unfortunately, there would be more strandings with the pups, which are those that are younger. And again, there was a statistically significant relationship between the age of the species and then the month as well. I also did look at species spaced out by the state as well. So overall, you can see that Rhode Island had the most number of calls, Connecticut the next, and then Massachusetts and Maine. So the gray seal, this will probably help inform their efforts so that they can send more people to Rhode Island and Connecticut and Maine, as well as Massachusetts, and kind of help the aquarium figure out where they will need to base more people based on the state. So they have Virginia and North Carolina and Florida and other things in here based only because they had other species transferred in. And again, there was a statistically significant relationship between the species type and the state in which the species had appeared. So some takeaways from all of this. I'm hoping that ultimately this will inform the aquarium as to where they can put their efforts, as well as the public once we hopefully make some form of deliverable. So hopefully they can see how the seals are impacted, how the numbers are, and what they particularly can do to stop strandings from happening or sightings as well. So we will need to continue to update the information for the rescue program because we only have it so that it's updated from 2011 up until now. So I don't know how we'll be able to do that, but we'll figure that out with the aquarium to see if they want to take on our efforts. The aquarium did ask us to see what percentage of calls they actually did respond to, but unfortunately, the log that they gave us didn't have any of this data. So there will be a need for the rescuers to put in more information if they want us to do some more analyses. I was also hoping that they would have more data about how the animal was stranded, entanglements, prop strike, or if it was just sick. And again, there was no information on this, so I think in the future that would be really interesting to explore why particularly these animals are being stranded, and then we can maybe make more informed efforts in those particular areas. What I learned personally is that there is a lot of importance behind data analysis in conservation work. R can be very tedious as well as Excel, but sometimes you do have to put a little hard work into that to then figure out the bigger grand scheme of things. And honestly, visiting the aquarium, I realized that this is such an underrated program that needs a lot more recognition. I think that people know it exists in some ways, but their facilities are not as great as they should be. And I think that they deserve a bigger platform. And I'm hoping that with the work that Sarah and I are doing, it can help inform the public as well as help their conservation efforts and hopefully let everyone know exactly what they're doing so we can make a bigger impact. I just want to thank my SIP advisor, who is unfortunately at a conference in Miami right now, the professors at the Bermuda Institute of Ocean Science, Sarah Callan, who Sarah and I worked with very closely, who is the Animal Rescue Program coordinator, of course, Jen, Kelly, and Derek, and the entirety of the Governeering Center, and as well as the Cape Liver Institute, and of course, Sarah. Thank you.
Ellie, I kind of feel like you've already maybe introduced Sarah, but I wanted my agenda up here again. Yeah.
It's my joy to talk about each and every one of you, right? So Jen again, just want to say, like, only in Goodwin could you have two amazing and unique, really talented people do a project kind of in tandem, but each bring their own strengths And, you've seen how amazing Ellie is, and I know Sarah will wow you as well. Sarah, you're an incredibly focused person, and I've just been so impressed. You came into the center with a little bit slightly different idea of what you were gonna do, but you stuck with your ocean passion. And I'm just so excited to see, because I know all that focus and passion and strength of the data analysis will reap lots of rewards. So without further ado, take it away, Sarah.
Hey, what's up, guys? My name is Sarah Padilla, and I'm going to talk about my SIP, which is called Analyzing Local Sea Turtle Stranding Data in collaboration with Mystic Aquarium and, of course, LE. So a little bit of background on me and why I joined engineering. So I'm a bio major with concentration in ecology and environmental studies minor. And I grew up in Hawaii, and my mom would always take us to the beach when we were younger. It's a picture of my sister and I. So that definitely sparked my passion for the ocean and everything it had to offer. And then I knew that joining good engineering would help me be able to combine my passions of environmental science as well as marine conservation. So part of good engineering is getting an internship between your junior and senior year during the summer. So my internship was at the University of Southern California in Los Angeles, and I was looking at how climate change affects the coral reefs, and my project specifically was called Comparing Measures of Algal Symbiotic Health and Thermally Stressed Acropolis Siricornis, which is the species of coral that I worked with. And I was lucky enough that the lab that I was working with was going down to the Florida Keys for the summer, so I was able to join them down there and help them run a heat stress experiment. And I was in charge of a couple different things like lab work, data interpretation, and data analysis, and I'm super grateful for this opportunity. So like Jim said, I definitely had like a very different idea of what I was going to be doing when it came to good engineering. So I came in my sophomore fall, and I was a computer science minor. So I was really interested also in marine pollution and that aspect, just because when we would go to the beach, my mom would always take long walks and just pick up all the trash that she found on the way. So my idea was to code an app that would allow people to track marine pollution when they went to the beach. But after taking a couple more computer science classes, I realized that that wasn't really something I was super passionate about, but I'm still definitely interested in marine pollution. Just decided to kind of put it on the back burner. So for the senior integrated project that I'm doing right now, I kind of talked about it a little bit, but we're collaborating with the Mystic Aquarium, specifically their animal rescue program, which is headed by Sarah Callan. And so they sent us like a call log of all their data, which is basically just a giant spreadsheet of all the calls that they've received since 2011 of different sightings and strandings that they had of various different animals. So they had like seals, turtles, dolphins, and manatees. But for our projects, Ellie focused on the seals, obviously, and I'm looking at the sea turtles. So we analyze the data for them, and we're hoping that they can use this information for their conservation efforts. So we had a couple of goals for the project, and when we were thinking about the data, we came up with a couple of different questions that we were interested in, that we thought that the aquarium would be able to use when they were kind of looking at their data and informing their conservation efforts. So we looked at what would be the most popular species that people called in about, what was the most popular time of year, what was the most common call type, so that was like sighting, stranding, or like transfer, and then the location with the most calls, so that's like typically anywhere in the Northeast is their jurisdiction. And then just some of our personal goals were combining our interests with the needs of the community was super important. So we want to help the community while just also doing something we were passionate about and like aiding aquarium efforts. So this is a picture of the raw data that we received. So as you can see, there's kind of a lot of columns. It's hard to read. But some of the columns that they did have in there were the accession code or the ID number. So those were the specific codes that they used to identify each individual animal. So it would have the year in there, species and gender, and then also other columns they had just separately were the date they found it, the call type, location that they found it, which includes the city and the state, as well as maybe the specific area for some of them, the species, the age, and then the comments that people made when they called it in. So after we tidied up the data, this is kind of what it looked like, and it was based on like the questions that we were focusing on. So the columns that we were left with were date, call type, city and state, as well as the species. So once the data was all tidied up, we imported it into R and we created bar graphs and ran chi-square analysis on them, which I'll talk about in a little bit. So just a little bit of background on the sea turtles that they found for their data. They found 4 different species of sea turtles. So it's the green sea turtle, Kemp's redleaf sea turtle, leatherback sea turtle, and loggerhead sea turtle. And if you don't know what a sea turtle stranding is, it's when a sea turtle will wash up on shore, either dead or alive. And if it's alive, it's very likely to be weak or injured. And this can be due to many different reasons, natural or human cause. So some of the natural causes would be cold stunning, red tide, which is like a harmful algal bloom that can cause a decrease in oxygen in the water and also spread toxins. And then they can also be hurt by disease or being attacked by a predator. And then some of the human causes that we were looking at was getting struck by boats, accidentally getting caught in fishing gear, and then getting entangled in other marine debris. So like I said, we created a couple of graphs and ran chi-square analysis. So chi-square analysis allows us to compare different variables 2 at a time, and they're both categorical variables, and we use them to see if the relationship between these 2 variables is statistically significant. So we tested most of the variables against each other. So as you can see, it's kind of a list of all of them. The numbers aren't super important for the presentation, but the p-value for all of the chi-square tests was less than 0.05, like Ellie said, which means that the relationship between all of these variables when compared with another one was statistically significant. So these are some of the graphs that I had. So this is a distribution of just the species types in general across all the states. So the most popular called in species was loggerhead, and then next was the leatherback, then Kemp's redleaf, and then green. And then they also had a bunch of unknown, which is probably because there are a lot of sighting calls. So people aren't really able to go out and see and figure out which like specific species it is. They kind of just might see it from a distance. So the next is distribution of calls by state. So for the sea turtles, it ranged through 4 different states: Connecticut, Massachusetts, New York, and Rhode Island, with Rhode Island being the most popular, and then Connecticut, and then not too many calls from Massachusetts or New York. And then this this graph kind of combines the last 2 that we just looked at. So it looks at species, but within each state. So it's kind of nice to break it down because, as you can see, the loggerhead was most popular for Rhode Island and Connecticut, but for Mass, it was the Kemp's redleaf, and then it was unknown for New York. So it kind of varies. So this graph looks at the distribution of sea turtle calls per month. So it's a little bit different than what Ellie found. She said that she found more calls in early winter, and for the sea turtles, it was a lot of different calls during the summer months, so like June and then through August, and then also early fall. So this could definitely be due to a lot of people being out on the water during the summer months, and then so the sea turtles are probably getting hit by boats, entangled in fishing gear. And then this graph is kind of like similar to the other one, but it breaks it down even further, looking at each different species specifically for each month, which is kind of nice because you can't always assume that there's going to be an even split for the number of each species in each month, or that the most popular species in general, which in this case was loggerhead, is going to be the most popular each month. Because like for July and August, let's say loggerhead is the most popular, but then once you move into September, it's actually the leatherback, but in November and December, the colder winter months, it's actually Kemp's redleaf. So the end goal for this project, like Ellie said, was that we were going to create a fact sheet of all the data that we found, and then hopefully turn this into a QR code that people can scan when they're at the aquarium, so they can kind of see what the animal rescue program has been doing, and also look at like the data that we found just to give them like a better idea. And then we also want to use this data to see how we can inform conservation efforts. So knowing things like the most popular location, the most popular species, the most popular time of year can definitely help them be more prepared when they're sending people out, like Ellie said. But I definitely learned a lot during this project, and I had a lot of fun. I learned about the importance of data analysis to conservation work, because during my summer internship, I definitely did a lot more field work and lab work, but I think this definitely was a lot more statistical analysis, which was nice to see that other side of it, because it's still really important when looking at marine conservation, and it helps them know what to be prepared for. But also this project helped me reaffirm my passion for marine conservation work. I know that like I've done like a couple of things in the past, but like with every new experience, it's definitely nice and reassures me like this is what I want to be doing. And so my future goals are definitely work in marine conservation, like I said, and then definitely probably in the area of like climate change and looking at marine organisms and how they interact. But before I finish, I just want to acknowledge a couple of people. First off, I'd like to thank Dr. Maria Rosa, who can't be here because she's in Miami for not a concert, a conference, maybe both. She's my major advisor and SIP advisor. She's super amazing. Sarah Callan, who is the Mystic Aquarium Animal Rescue Program Manager, as well as everybody at Good Wineering. So thank you, Jen, Derek, and Kelly, as well as Michelle Neely for teaching seminar this semester, as well as the people down at USC that I worked with over the summer. So Jenna Dilworth, Carly Kinkle, and Dr. Diane Kim, as well as the Moat Marine Laboratory staff in Florida Keys, and of course, Ellie Piper. Thank you.
Thank you, Sarah. Thank you, everyone. I want to, we do have some time for questions, for Q&A. It would be awesome if those of you from session 2 would like to come on up to the front and maybe see if there's any questions. So Ellie and Sarah. Yeah. Yes. All right. Any questions for the group?
I was wondering if you looked at any specific programs. Well, I was thinking about like the building energy efficiency ratings in New York. Does that actually do anything? Do you know what they mean?
For like New York, the like most recent policies were passed like 2021, so it was like hard to see exactly where their like results gone. But like I know like this is like the first. This is like kind of like, or like we just passed like the first year of them actually like keeping records and everything. So like it's obviously like gonna be like kind of like wait to see. It was the same because like they were both like kind of semi-recent time frames like taking place like after the Paris Agreement. Kind of like was also part of like the intention too. But
What about the compost system in New York City? That's been going on for quite a while.
I didn't look at waste, so I didn't get too much into that. Yeah.
Sure.
Yeah, another question for you. I saw in your charts that the amount of emission per person in New York is about half what it is in New York. Yeah, that surprised me. Do you have a breakdown of the baseline for each city?
I don't have it on like the top of my head based off like everything, but the biggest sector for like each one is buildings, if I remember from the top of my head. And then next it'll go buildings and transportation are always in the top 2 or it's 3, which is part of the reason also why I chose them for the sectors. I think a lot of it just has to do with like more building efficiency, and a lot of it has to do with more like efficiency measures for why New York's more has less emissions than Rio per capita.
I have a question. How big were the plots that you were sampling?
Yeah, so both for the trail side and non-trail side plots, they were both like 20 by 30 meters. Or they were equal area, like along the trail, I wouldn't do like 20 by 30, but I would do like a longer, skinnier area to get more just like along the trail. And then the undisturbed area would just be 20 by 30.
I have a question for Ellie and Sarah. When I looked at those numbers, Rhode Island had a gigantically disproportionate number of strandings and problems. Like, what's up?
Oh. He's like, what's wrong with Rhode Island?
Yeah, I mean, it's tiny coastline and popular, I mean, just.
They did have data from Block Island, so that might also have influenced that. So I don't know if the seals and the turtles like Block Island a lot. They like to vacation there, but so I guess maybe my guess would be like awareness of the program. Maybe more people in Rhode Island would know about the program since it's such a like coastal state as opposed to like maybe people like in New York and Connecticut. Which I guess is
It is called the Ocean State, so.
true. Yeah. So it's that.
Another question for you too. Was it difficult, like, handling the seals? I doubt they liked being handled by people.
Okay, well, we didn't get to do much manhandling ourselves. We went there on a day where the vet was like performing their routine exams, and they were actually sending out one of the seals to do just to be released. So they were doing a tagging that day too. So there were like a lot of people in this like really small facility. It's like honestly maybe the size of this classroom, maybe a little smaller actually. So it's a really small facility that's like right inside behind the aquarium. But yeah, there's a lot of squirming, and they yell a little bit, and you have to sit on their fins. It's a little sad, but it's for the best.
Yeah, there's like 5 people on like one seal just trying to
Yeah.
hold it down while they're trying to like satellite tag it. So
We were told we weren't allowed to like boop the noses of the seals. That was one thing I wish I could have done, but we were told we couldn't.
Yeah, I was gonna ask LA a question. So, the data for gray seals and the hooded seals showed kind of a peak, right, in the kind of spring, winter time, right?
Mhm.
A single peak. And I was just, you were talking about migration issues. It's interesting to me that there was a unimodal, like a single peak. Is that, like, if they were migrating past north and south, wouldn't you almost expect it to be bipolar? So is it possible they're actually wintering in this area?
I was thinking about that too, and I couldn't really come up with a conclusion. That would make sense. They don't tend to live here though, so that's why I was like, maybe it's based on migration. They're kind of just something happens along the way where they stop. But that could be definitely something to look into a little bit more. That's a good point.
I have a question for Quincy, but I want to make sure if you wanted to jump back in with the question. Okay, Quincy, you mentioned in just surveying fungal diversity, there's a moment where you mentioned that you were able to get kind of good resolution of how many genera you're talking about, but it was tougher at the species level,
Mm-hmm.
And that just my brain kind of latched onto that as a really interesting detail, and I was just kind of wanted to see if you could say a bit more about that. Like, it's like one question is like, what does species even mean for fungi? Sorry, but you see what I mean? I'm just kind of curious. Is that pretty common in like mycology that you just measure diversity with looking at genera? I'm just curious.
Yeah, well, so I didn't get to touch on this too much in my presentation, but measuring fungal biodiversity specifically through fruiting bodies is pretty common practice, just because of the simplicity with being able to observe and collect them. But mushrooms can be very similar between different species, and it can often come down to microscopic differences in order to tell one species from another. So especially like, it's a mushroom only lasts so many days sitting in your fridge. So it's hard to be able to identify all of those differences in a short amount of time. And also, these mushrooms are just out in the wild. There are animals that are coming through. There are insects and slugs and things that like to snack on them. So you're not always going to have the perfect specimen either. And you might go out one day and find a mushroom that is fully developed, or you might have one that's like, it just sprouted out, and so you can't quite see all the features yet. So there's a lot of complexity there.
For foraging purposes, were there any differences between like the edible mushrooms that someone can actually find versus just all the general diversity? And then do you have any overarching recommendations for if you were to go foraging? Like what were the like species indicators that you're talking about? I don't remember what the term you used.
Yeah, so I did not assess the numbers of edible versus non-edible fungi in all of my collected specimens, and part of that is because like if I was only able to identify to the genus level, there's like lots of different species within that genus, so it's going to depend on the species to know if it is safe to eat or not. But as Eric was kind of mentioning, there is a pretty big mycological community in this area, and so there's a lot of information like on Facebook, and I think in the fall there was even like a mushroom festival that happened in Groton. So there's definitely like a growing community that is having that conversation and trying to specifically hone in on the edible species.
Did you eat any mushrooms?
Yeah.
I may have nibbled a few, but only under Eric's supervision. I didn't trust just my own supervision. But yeah, I definitely learned a lot about how to examine mushrooms, and taste can even be used to help identify species. So
I have a question on the sea turtles. So does the Mystic Aquarium, I know this was about stranding, but what about sea turtles nesting and, the babies getting back to the ocean? Do they have a program that follows that as well? And are any of those like nesting turtles, like, misidentified as being stranded? And do you know it, or did you not get into that at all?
So I didn't look into like nesting and stuff too much, but Ellie did just whisper over to me if you could hear that they do have one, which I guess I probably could have guessed that, but yeah, but it's a volunteer-based program if I remember correctly. But yeah, thanks.
Since you said they were looking, or they put down gender, was there any differences? I mean, I was thinking like with turtles that females would go on to land more often if they were more likely to get stranded or not.
I didn't look specifically at the gender just because not all of them were known. So like in the codes, sometimes it would have like female or male, but I think they have to do like pretty invasive things like to like, figure out if it's a male or a female for turtles at least. I don't know about seals, but yeah. And like also some of them were like sightings rather than stranding, so they weren't able to like bring them in. But they did put as much information as they could, like regarding like age and gender and all of that. Yeah.
One more question then for both of you. So a lot of these calls you said were just sightings rather than stranding. So is part of your outreach getting the public to actually, call and leave data about just spotting the, turtles or seals?
Mm-hmm. Yeah, I think the sighting data is honestly like some of the more important data, just because then it's easy for the aquarium to like almost track some of them. Like there's more in Rhode Island and things like that. So then they can send people out there and just kind of have a general knowledge of, okay, there's more here, there must be a reason. So that data is definitely important. People should be calling if they see things. I think that a lot of people think if I call that it's going to go badly or something, or that like they shouldn't necessarily call if they see something.
It's an emergency.
Yeah, but calling is always a good idea.
So why your deliverable would be so important that if everybody would start calling just because they spotted them and then have some more data.
Yeah, I agree. I think that obviously outreach and like getting people to know about the program is definitely super important. And then I know they talked to us a little bit about how they have a volunteer program, so you can sign up and kind of learn how to like go out there when there is like a stranding. They'll do this thing where they like protect the area, and they'll have somebody like kind of on watch if they can, like 24 hours. So that's a volunteer program that they have that you can kind of sign up for and learn how to do. And then like you'll kind of be on call and they'll call you out there and you can go like help out. Yeah. So
Any other questions? I think this is a good moment to wrap up the evening, say thanks to the four of you. I kind of just want to say thanks to all of you two for joining us late on Thursday evening, especially family and friends. And one last word of congratulations to all of you seniors for finishing up this research. It's just really exciting to see what you can do. So thanks and have a good night.